Alright, so what we're looking at here is Unit 6, Lesson 6, and we're going to look at the second formula that was on that table, and that is, is the heat of fusion. So the heat of fusion, remember the term fusion is another term for melting. Heat of fusion is the amount of heat that's needed to melt a substance, to change a substance from a solid to a liquid at its melting point. Every substance has its own heat of fusion. For water, the substance, for H2O, the value is 334 joules per gram. That's actually on your reference tables. Now, what does this number mean? Well, that means for every gram of ice that you want to melt, that ice must absorb 334 joules. So basically what you have to be able to do in this section is if they give you an amount of ice, let's say 10 grams of ice, you should be able to figure out how many joules of heat would be needed to melt that 10 grams of ice. And it's relatively simple. They give you the formula on your reference tables. To calculate heat of fusion, all you have to do is to know how much ice you have, that's M. The heat of fusion of ice is 334 joules per gram. They're not going to ask you about the heat of fusion for another substance. And you simply multiply the amount of grams of ice times 334 grams, joules per gram, and that gives you how much heat you would need. So here's an example. How many joules are required to melt 255 grams of ice? So you have 255 grams of ice, a large amount of ice. How much is it going to take? How many joules of heat are going to be required to melt it? Well, the mass of the ice is 255 grams. HF, the heat of fusion, is a constant, is 334 joules per gram. You plug those in and you get 255 grams times 334. Notice what's going to happen is that the units, grams, will cancel out and you'll be left with joules, which is what you should be left with. So in order to melt 255 grams of ice, it would require the absorption of 85,200 joules of heat energy. Now if you look at the second example, it's basically the same process, but in this case, instead of 255 grams, you have only 150 grams of ice. So obviously the amount of joules is going to be significantly less. And it's going to turn out to be about 50,100 joules. Notice it could be in scientific notation, or we could change it to kilojoules. So kilojoules, you'd take the decimal, which is here, and move it 3 places to the left. That would be 50.1 kilojoules, or just 50. So that is the heat of fusion of ice. Okay, so the next lesson is going to be